Hey y'all, it's your soft-spoken scientist. Today we're doing Dalton's law of partial pressures, how to handle gas mixtures, and how to solve those classic gas collected over water problems. I'm going to do all of this step by step. So the first thing I want you guys to know about Dalton's law is that it's essentially about partial pressures, right? Rule number one is that the total amount of pressure is partial pressure 1 plus partial pressure 2 plus partial pressure 3 plus blah, 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 right? It's an endless cycle depending on what is given in the problem. You're going to add them all up and try to get to 1.0. Rule number 2, each gas contributes a partial pressure. Rule number 3, if it's over water, it's P gas that's dry that equals P total minus PH2O. Okay? And the other way you could see is that the P total equals P gas plus PH2O, right? So then you can just go from there. And so you could say, okay, if I minus by P total, on both sides, but then I minus by P gas, you have negative P gas equals negative P total plus PH2O. But if I divide everything by -1 to get rid of the negative P gas, because that's not even a thing, you will end up with P gas equals P total minus PH2O. And I will never use this pink again. I'm sorry, that was so bright. But you guys get, see, bam, bam, led me to the same formula. Why this works, okay, let's talk about it. Pressure is caused by particle collisions. In a mixture, each gas collides independently, so pressures add, okay? Let's do practice problem number 1. A container has 3 gases: oxygen pressure of 0.45 atm, nitrogen pressure is 0.38 atm, carbon dioxide pressure is 0.12 atm. Find the total pressure. Well, what's the total pressure formula? We know what it is. The total pressure, P for pressure, equals PO2 plus PN2. This is what they gave me. Oxygen is known as O2. Nitrogen is known as N2. Carbon is just known as C. And then dioxide is O2, so CO2. So plus PCO2. So the P total is 0.45 plus 0.38. And then I have 0.12, right? So what I'm going to do is I'm going to add all of these up, and I'm going to get the P total equals 0.95. It's not 1, but it is what it is. This is what it is. That's the answer. Number 2, practice problem 2. A gas is collected over water. The total pressure measured is 760 millimeters of mercury. Hg is mercury, by the way. The vapor pressure of water is 24 millimeters of mercury. Find the pressure of the dry gas. So let's start with the formula we do know. We know P total equals P dry gas plus PH2O. And they want me to find P of dry gas. So I'm going to minus P of dry on both sides. And you may be saying, well, why are you doing that? Well, the thing is, I need to isolate P dry to find out what the formula is. So it cancels out here, and I have P total minus P dry gas equals P of H2O. Okay? So I'm gonna minus P total. I'm doing the same formula twice for y'all to see it. Because I don't know what to do with P dry, I need its formula. This is going to cancel out, and I'm left with negative P dry equals PH2O minus the P total. We did it up there, we're doing it down here. Practice makes perfect. I don't want to know what negative P dry is. I need to know the pressure of dry gas. So I'm going to divide both sides by -1 to get rid of that weird negative sign. Divide by -1, divide by -1. Why did I divide -1 on all three of them? Guess what? What I do on one side, I gotta do to the other. So the negatives will cancel out, and I have P dry divided by 1, which is just P dry. Anything divided by 1 is itself. So you got P dry equals negative P H2O plus P total. This just looks a little weird. It looks too much like algebra, and we're in chemistry. So I'm going to rewrite that as P dry equals P total. It's positive, right? Minus PH2O. So this is the formula we got to use. So now I can apply what I know. I know the total pressure measured is 760 millimeters of mercury. That's the total. They told me that, and they will always tell you those things. So 760 minus, let's see, vapor pressure of water is 24. So P dry equals 760 minus 24, which is 736 millimeters of mercury. Bam. Problem 3. A gas mixture contains helium that is 2 moles, and then neon, which is 6 moles, and the total pressure is 1.20 atm. Find the mole fraction of helium and the partial pressure of helium, okay? So let's start with this. We need to first find the total number of moles. And the only way to do that is by adding them up. So if we take a look here, we have 2 plus 6 for n total. You got 2.0 plus 6.0, which is 8.0 moles, right? That's the n total. Step 2 is the mole fraction. You have to take the mole fraction of helium all over the number of moles total. Okay, so we have 2 divided by 8, which is 0.25. Okay, so I'm going to use Dalton's form to get the pressure now. So it would be P of He to get the partial pressure of helium equals 0.25, the moles of helium, times the total pressure, which is 1.20. By plugging this in a calculator, I will get that the partial pressure is 0.30 atm. Okay, partial pressure is proportional to how much of the mixture is that gas. Mole fraction tells you the fraction of particles from that gas. So that's how you would address this one, okay? Let's look at problem number 4. A gas is collected over water. Manometer reads 101.3 kPa at 30 degrees. So these are all important, right? At 30 degrees Celsius, pH2O is 4.2 kPa. And they want us to find the pressure of dry gas, okay? So P dry is P total minus the water, right? So 101.3 minus 4.2. When you subtract that, you will get 97.1 kPa. Now, what do we know about 1 atm? This is just something that will be given to you by your professor, so don't freak out if you don't know it. But 1 atm is 101.3 kPa, okay? So I'm going to convert into atms because I forgot to mention it, but usually for these, they may ask you to convert into atms, depending on your teacher. So a lot of times I want you to do that. So you'll take what you got, which is 97.1 kPas, and you're going to divide by 101.3 kPas to get for every 1 atm. I cancel out kPas. I never see them again. I'm in ATM mode, which is what I like to see. And I'm at 0.959 atms, which is roughly 0.96 atms. And that would be my answer. For First, we subtract water vapor in the same units. Then we convert to ATM only because the problem asks or because your professor may ask you. Granted, if they never asked, then 97.1 kPa would have been your answer. Okay? So that is how you would do that. But if I told you guys, here's a conceptual one, right? If there's a container that has a mixture of gases at like constant temp, right? Oh yeah, I promise I'd never do that color again. Constant temperature. If you remove half the moles of nitrogen, okay? You remove half of it, but leave other gases unchanged. They want to know what happens to P of N2 and the P total. So here's the deal. The answer is this. PN2 decreases by half. And the P total would go down, right? Because P total is made up of, you know, nitrogen, partial pressure of nitrogen plus the partial pressure of something else. But it's kind of like this. If the P total is like $50, right? But then the person, partial pressure of nitrogen is a person, and they were supposed to bring to my party $30, but they only brought a 20. My P total will go down because I'm gonna be down at 40. You see what I'm saying? The P total also drops because one component dropped. Like 5 plus 6 is 11, right? If this goes down in value and it's 4, well, 4 plus 6 is now 10. So the total went down, okay? Partial pressure depends on how many particles of that gas are present. Fewer nitrogen particles means fewer collisions from nitrogen, okay? I really want to thank you guys for tuning in. Please hit that like and subscribe button. It will help my channel grow even more and hopefully make a difference, because that's what this channel is about. So please do that for me and yourselves. And know that STEM is for everybody, especially you. Keep working hard.